Hey folks, so today I'm working on a new project in the house. So this stove and oven combo from GE, it's the GE Spacemaker. It was with the house when we bought it, and pretty rapidly what happened is these plastic mounts for the oven door handle broke off, and so the handle just became loose. And so unfortunately we've been living with this for a while. You can still open and shut the oven with these handles, but I wanted to get it replaced. So what we're going to do today is we're going to take these off of the door, and we're going to model them in SolidWorks or 3D modeler, and we're going to take that and reproduce some 3D printed replacements for this. So this side's still on. Obviously this side's been taken off. The way that you get to it is just by undoing these 3 screws at the top, and then this plate actually slides up, and then this slides out. This has the glass in it, so you have to be careful. And then there's one screw right here, you can see that, and this metal plate that sits behind here, and you'll see a little bit more of this when we reassemble it, and or I might film taking that one off. But basically this screw just goes into the bottom of this plastic piece. So we're going to take this plastic piece, we're going to model it, and make sure that it matches this bar. The bar is going to be a little bit more complex because I don't know if you can tell, but it has a very slight bend to it. So I have to make sure I'm getting the correct angle on that to make sure that the actual connection point matches. So I will bring you back when we've started doing that modeling. Okay, so here is the right bracket, and I'll talk about why I'm delineating between right and left with these designs. This is the right bracket for the oven, and this is it fully modeled, but I'm going to roll back the modeling and show you basically how I constructed this. So if you're trying to learn how to do some 3D modeling, this will just kind of give you an overview of my thought process by how I generated this shape for the 3D print. So we're going to roll this back to where there is nothing except for the original sketches, and they're all hidden right now, so I'm going to show you them. Actually, we're going to roll back. We're going to keep the loft, but I'm going to show the sketches. So this is the start, was the loft that I did. So basically the loft tool, you draw one face somewhere and you draw another face somewhere, and then you give it some information to draw a shape to connect the two, basically. So it's trying to connect that one face to the other face, and it's lofting it. And you can kind of see by the icon that it's changing from, in this case, a square to a circle. In my case, it's from sketch 1, which I just highlighted there, to sketch 5, which is there. So this is the face here that will impact the oven glass surface, and then this is the face that the metal bar will go into. So if you look at sketch 1 here, I modeled it to match the overall dimensions of the bracket. You can see I don't have any of the curvature in, and I'll show you how I did that a little bit, but I started with just the base rectangular shape. It's a slight angle. You can see it goes from 1.45 to 1.30 inches. And then, so that was my first sketch. My other sketch is actually been done on a 3D sketch here. So The 3D sketch, which I've just highlighted here in blue, is actually a plane that I placed into this model that references the angles shown here. And the way that I did that was I made, so this is, this line here that I'm highlighting is in plane with the flat part that would go against the glass here. And then this is also in plane, but if it was the front face, kind of. And this is measuring the angle that the end that goes to the oven bar is. And the oven bar is actually has an ever so slight arc to it, which is what you can see here with these construction lines. So this bottom line here is actually parallel with this flat line, so it's just flat. And then I've done a 3-point arc from this end to this end, which I've measured off of the bottom of, or I guess relative bottom of the oven bar, and I determined that it goes up 0.2 inches. So the center, I've made it go 0.2 inches. And then what I've done over here is I've said, okay, this line that's coming off here that's now highlighted in blue, I want that to be tangential to this curve, which means that it will match the angle that I need to cut into this piece to allow the bar to slide in appropriately. And the way that I've done that is basically once I created this line here, I said, hey, when that line exists, I want this line here to be perpendicular to it because I want this face that is working relative to this line to also be perpendicular to it. And it just so happens that when you do that, you get the angle that you need for this face to be to interface properly with the oven bar, which is 87.4 degrees Fahrenheit. I want to be clear that this line, and if you're not familiar with SolidWorks, this may be a little abnormal to you, but this is a light gray, and this is a full black text. That means this dimension is driven. So this dimension select is a driven dimension. Its value cannot be changed because basically I wanted to be able to highlight what the actual angle is that I inherently created by measuring the arc of the oven handle using this line. So I didn't measure this angle. I measured the rise of the handle as 0.2, and then relative to that developed this line here to give me that angle. So then what I did with the loft, and I'm going to edit the feature so you can see how it works. So I selected the two sketches that I'm working from, and then I used guide curves. There's different ways that you can make the loft work, but I used guide curves. And so I just took relative measurements on these groups here, and those guide curves are actually drawn, sketch 6 here, they're actually drawn in parallel or in line with both this flat line here and then this angled line here. And they basically just define how the loft is going to extrude itself from one face to the other face, which is highlighted well when you go to view the feature. You can see how it's defining that profile as it goes, and it's defining where it's putting these faces as it goes up. So that gave me the generic shape that I needed, right? And then I extruded a little bit off of that face because most of these measurements were taken off of the broken piece, and I knew that there was more piece that extended out, and I also wanted to make sure I had enough surface area when I made a cut through this to be able to hold the bar in place. So that boss extrude is literally me just taking sketch 5 again and extruding it in the other direction. So the loft took it from there to there. The extrude took it the rest of the way. And then let me hide some of these sketches just so that it's easier to see what we're talking about here. I'll leave that 3D sketch there because that's important for the cut extrude. So then with the cut extrude, if I show that sketch, what I did was I drew another sketch here that is the actual cut sketch. So if I roll this back, it'll still show it. So you can see I actually drew it on this face here before I even did the boss extrude. And what's interesting is what you'll notice is this line here is actually longer than this line here. And that's because the profile of the bar actually is the same way. It's a rolled metal, or it's like sheet metal that's been rolled into the shape that it is. So it's probably been stamped in some way. But because of that stamping process, one side is slightly bigger than the other, which is why I've defined this as the right bracket. And then there's another bracket that's the left bracket where this is reversed, where this line is on this side and this line here is on the other side. So I keep the symmetry even when I generate it again. So then what we can see here is, so I drew that, and then it exists actually inside this sketch, or in these extrusions, right? It exists internal to that. So then when I did this cut extrude, what I did is I had it, the blind, it goes in 0.4 inches in that direction. And then in direction 2, which is outward, which is this direction the arrow is pointing, I just had to go through all, which means that it just cuts through all of the existing material there. And so that gave me my cut into there. I'm going to hide this now. And I'm going to also go hide this 3D sketch as well. What's still showing? Oh, all the loft is still showing too. So let me hide those. It's just a little cleaner to look at. So now this is the basic shape we have, but I wanted to make it look a little bit more like the original ones, which have nice rounded corners, right? So I started filleting the different pieces, so you can see the difference there. So I filleted the top, and then I also filleted these angle pieces here to just round it out and give it a better profile. And then this cut extrude, you just didn't see anything. It's because it's right here. So this is me modeling the hole that the screw goes through. So if we bring this down, you can see I sketched that out. This opening is dimensioned to accept an M5 insert, which I am expecting to use to replace the screws that just screw directly into the plastic, because I want a metal insert. And then you can see I also did another cut extrude, which just showed up there, which is inside that, and that's to give me clearance for the length of the screw. So if the screw goes through the metal insert and then keeps going, I want to have some clearance behind it just to make sure that the screw doesn't bottom out and then doesn't grab the oven front appropriately. And then the last thing that I did is I didn't like how this was just a flat face, because the original material that they used, it looks like it was a injection mold, so they were able to use very thin walls. So I didn't like how thick this looked, even though structurally I like how it supports the bar better and could potentially prevent the cracking that I originally caused this issue. So I applied a chamfer to that to just bring it down to a smaller opening, but still maintaining a lot of that main material to keep that dimensionality, or to keep the structural support there. So this is the right, and then I also built a left bracket, which I'll go ahead and open here. Let's see here. Or actually, let me just open the assembly, because that just shows you them both at the same time. Go ahead and rebuild this. Yep. Okay. So what this is me verifying that the faces are symmetrical here. So this right here that I just clicked on, that is the, or actually, let me flip this around so it's clear. This is the left bracket, and this is the right bracket. So the right bracket here is the one that we just went through. The left back bracket is literally just me resaving the right bracket. And then, like I said, I switched this dimension here with this dimension here so that it is symmetric over here, or on the other side, it's the other way. And that means that the bar will be able to go between the two. So you can see it was pretty easy for me to do that because I just basically had to modify the dimensions I had made for those sketches to easily replicate the part for the other side. And it is identical otherwise. So that is the modeling. And the next thing you'll see is it running through the printer. Okay, so I've test fit the print now, and what you can see is that it's laying flat but still maintaining the bend in the bar. So I think it should work. I'm a little concerned about the distance here. I don't know if I had enough depth in the cut here, but we'll see here shortly whether that works. I'm going to do a test fit real quick. Okay, so on this side I have the screw sticking out. I'm holding the glass up with my knee, and then this side you have the hole there. And so what I am seeing is if I just hold this up and match up the hole spacing, it looks like I'm off quite a bit on this side. So I'm going to need to basically make the cut into this part here quite a bit deeper to actually get the holes to line up. But this was a good first approximation, I guess. We'll just have to modify that cut to be a little bit deeper into the profile. So I'm going to measure those separations without the camera on so I can actually get a accurate measurement, and then we are going to go ahead and reprint. Okay, so we are back in the model after taking our measurements from the test fit. So what we discussed is that basically this depth here from this front face to here, so that spacing there, and actually I can measure it here. Let me measure this real quick. From there to there, so that 0.9 inch depth is too shallow. So basically from taking the measurements off of the oven, what I've determined is that overall, in terms of the length, we need to be shorter between both brackets. We need to be shorter by 0.231 inches, which is almost a quarter inch, which is what I was eyeballing when I looked at it. So what I'm going to do is I'm going to extend the original cut that we did here, this cut extrude that I showed earlier. So I'm going to edit this feature. And so this 0.4, like we said earlier, is this cut here. And hold on, it's this right there, so that direction, right? So, and then we don't want to mess with the direction too, because we still want it to go all the way through. So basically, because it's 0.23 too long, I'm going to extend this by half of that, because I want to also extend the other side so that it's symmetrical. So I don't want one of the brackets to be deeper than the other, because then the bar is not technically sitting centered on the oven. And because measurement 0.23, it's pretty close to 0.25, and if I extend it a little bit further, that gives me some flexibility in the spacing. So basically that would allow me to have 0.01 inches on either side to play with in terms of flexibility. I might go a little bit further. So what I'm going to do here is I'm going to just assume 0.25 So 0.25 divided by 2. And what we can actually do is we can actually type that in here with an equal sign. Do plus 0.25 divided by 2. And then if I hit that, it should have updated the extrusion. If I go back to edit feature, you can see that it still exists in there. So that has just extended the cut deeper into the body of the bracket. And then, so that's essentially the minimum extrusion there that we need. And I may add a little bit more flexibility there because 0.01 is a pretty tight tolerance. So what I think I'm going to do is I'm going to add plus 0.02 to it as well, just to give us a little bit more depth there. Because we have the room, the bracket has ability to support additional extrusion there. So that overall addition should give me some flexibility with that. And then if I don't like how tight that is, then I can always add like a little bit of like cushioning in there. Like I could just put like a piece of foam behind it just to make sure that it's rigid. So that is it for the right bracket. So we're going to go ahead and save that. And then I'm going to also save as new. I need to save a new STL. And I'm going to save it as Rev1 so that I have a differentiation between the previous let me save that again. I think it was because I was selected the cut extrude. I just want to make sure that it actually saved the full project. Or full. Yes. Okay, cool. And then I'm going to go ahead and do the exact same thing to the left bracket. Plastic left open. So I'm going to go into here, going to edit the feature. And like we see over here, it also is extruded 0.04 or cut 0.04 or 0.4, sorry. And we're going to do the same thing over here. So it's going to be plus 0.25 divided by 2. And then I'm going to add the same margin over here, 0.02 as well. And you can see that depth increased. Okay, and then we're going to save that. And then I'm also going to save this as a new STL. And the reason why I'm not really worried about saving like a Rev1 file for the actual SolidWorks model is because of how I've done this. I've dimensioned it with a equation. So if for some reason I come back and I'm like, oh man, like I really messed up that measurement, like I was completely off, then I can come back here and I can see what I did already. I don't need to like have an entirely different file just to save this change. So yeah, so that is all updated, and I'm gonna go ahead and run it again on the 3D printer, and I'll bring it back when the new ones are printed. Okay, so I have the new 3D printed pieces with the adjusted depth. So I'm just going to kind of hold them up, see how the alignment looks. And if I line these up here, looks like those holes line up pretty well. I don't know if you can see them. I don't know if that helps. Let me see. There we go. So that lines up pretty well between the two. So I'm going to go ahead and put the inserts into these holes here, and then we'll see if we can attach it to the oven. So my soldering iron is warmed up. It's up to 300. And I did a test of this last night with one of the spare pieces to make sure that it actually worked. So this is one of the other pieces that didn't fit. And this is one of the M5 screws I'm going to use. So it inserted in there nicely, had no issues, doesn't seem to want to pull out immediately. So we're going to go repeat the same thing here. So I'm just going to take one of these inserts here, and we're going to go ahead and put it into this opening. Let's see. And since I printed these at an angle, it's not a perfect circle, so it doesn't sit perfectly, but we're just melting the plastic around it anyway, so it doesn't really matter. That's one of them. We got a little bit of plastic on the tip, but that's okay because once the tip cools off, you can just peel that right off. Flip it around, and we'll go ahead and do the other side. Okay, that looks pretty good. Alright, and we're going to let those cool off for a little bit, and then we'll go ahead and try and install. Okay, so we got the handle, we got the screws, we're going to go ahead and install it. Okay, and just like that, it's done, and feels pretty solid. No real flex in them. So, and the spacing adjustment that I made to make sure that the holes lined up is perfect. Like, I didn't need to put any shims in the bar at all. So I think that's it. If you need a copy of these files, I can get them to you. And if you like the video, I'll be making some more videos, both 3D printing and non-3D printing. So stay tuned. Thanks.